All right, this video slide presentation is going to be on pressure math problems. Preface as always, I claim no ownership to any of the questions or materials presented in this video, as everything I found is sourced off the open internet. In the following slides, I have, to the best of my knowledge, presented the proper formulas and answers to study these questions. This is a study guide for myself. Making these PowerPoints has helped me learn and retain the knowledge. If watching them helps you, that's great. So this is the formula conversion table off page 1 that's given to you by the state of Florida for the exam. Like I always say, if your state gives you one, you should get familiar with the one that you use. The conversions that we're going to be using are the 1 PSI is equal to 2.31 foot of water head. 1 foot of water head is equal to 0.433 PSI, and the 1 gallon is 8.34 pounds. So here they are highlighted. And I'm not going to keep this up during the slides. We'll just add them as we go. So question number 1. What is the PSI at the bottom of a tank if the water level is 24.3 feet deep? The first conversion we're going to use is the 1 PSI is equal to 2.31 foot of water head. Now remember, when we do the math on this, what we want to cancel out has to be at the bottom, and that will determine whether we're multiplying or dividing the 2.31 foot number in the problem. So because we're trying to get rid of feet, the 1 PSI is equal to 2.31 feet. It's going to go on the bottom. So we're going to be dividing the 2.31 into 24.3 feet. So the feet cancel out. So you do the math. The 24.3 divided by 2.31, feet cancel out. You're left with 10.52 PSI, because that's the answer we're looking for. So the other conversion you can use to solve this problem is the 1 foot of water head is equal to 0.433 PSI. And again, remember what we want to cancel out has to be on the bottom, and it will determine again whether you're dividing or multiplying. So in this case, for the 0.433 PSI per 1 foot, foot's going to go on the bottom, so we're going to multiply the 0.433 PSI. So 24.3 foot times the 0.433 PSI per foot. The feet are going to cancel out, and you're left with 10.52 PSI. Question number 2. What is the depth of water in a lake if the PSI is 40.7? So I'm going to use the 1 PSI is equal to 2.31 foot of water head. This time around, we want the PSI to cancel out because we're looking for feet. So 40.7 PSI times 2.31 foot per PSI. PSI is going to cancel out because it's on the bottom, and you're going to be left with 94 feet. So now we can use the other conversion. The 1 foot of water head is equal to 0.433 PSI. Again, we want the PSI to cancel out, so we'll go on the bottom. It determines division and multiplication. So 40.7 PSI times 1 foot per 0.433 PSI. So you're going to divide the 433 into 40.7. Your PSI is going to cancel out, leaving you with feet. And again, the answer is 94 feet. So just to reiterate, and we'll keep going through the next few math problems. I'll just probably put them on the slides together. The 2.31 per PSI and the 0.433 per foot are interchangeable for answering these questions. All right, so question number 3. What is the PSI at the bottom of a clear well if the water level is 19.05 feet deep? Again, you can use either or on the conversions. The 1 PSI is equal to 2.31 foot of water head, or 1 foot of water head is equal to 0.433 PSI. And you're going to set these up based on canceling out, as in this problem, the feet. So the 1 PSI to 2.31 foot of water, you're going to divide by 2.31 to cancel out feet. And then using the 0.433 PSI per foot, you're going to multiply across because you want to cancel out feet. And you are going to get the same answer. Like I said, in the top, you're dividing by 2.31 feet to cancel out feet, which will leave you with 8.25 PSI. And on the 0.433 PSI times 19.05, the 1 foot's on the bottom, feet cancel out, leaving you with 8.25 PSI. Question number 4. A lake is 148 feet deep. What is the PSI on the bottom? Again, here's our conversions. Setting up the problem for the math is what you want to cancel out. We want to cancel out feet. So 148 feet divided by the 2.31 feet because it's on the bottom, canceling out feet. 148 feet times 0.433 PSI because foot's on bottom, so it will cancel out. I did want to show the slight variance when you do these math problems. So your feet are still canceling out because it's on the bottom, right? But before you round, when you divide by the 2.31 foot, you get 64.069 PSI. And when you multiply by the 0.433 PSI, you get an answer of 64.084 PSI. Of course, when you round these down, the 9 changes, the 6 goes to a 1 and the 8 goes to a 1. You end up with the same answer, 64.1 PSI, just slight variations before rounding. Question number 5. If your standpipe is 90 feet tall and 35 feet in diameter, what would a pressure gauge read if the gauge was 5 feet above grade? All right, so they give you some extra numbers in there that you don't need. Diameter is not going to change anything. Like I said, this is all based off the feet of water. So your gauge is 5 feet above grade, so you're not reading it from the bottom. So we're going to subtract 5 feet from 95 feet. You're going to get 90 feet. Again, 1 PSI is equal to 2.31 foot of water head, or 1 foot of water head is equal to 0.433 PSI. Again, you're going to set it up on what you want to cancel out. We're looking for pressure. So feet are going to bottom to cancel out, leave pressure. Do your math. Like I said, your feet cancel out. So it's going to leave you with just PSI. Like we talked about in the previous slide, the answers aren't exactly the same, but when you round, they will be. Go ahead and round. They both end up 39 PSI. Question number 6. The hydraulic grade line is located 150 feet above a point in the pipeline. What is the pressure at that point in the pipeline? All right, so it's same formulas. This is pretty straightforward. Again, we're looking for pressure, so you're going to set them up to cancel out feet. 150 feet divided by 2.31 feet to cancel out the feet, Leave you with PSI, 150 feet times 0.433 per foot. You cancel out again, 64.93 PSI or 64.95 PSI, which will both round to 65 PSI. Question number 7. A rectangular tank measures 8 feet by 12 feet. Water in the tank is 12 feet in depth. What is the pressure in pounds per square inch on the bottom of the tank? Again, they've given you more information than you need, because all you need is the depth to calculate the pressure. Again, same formulas. You want the feet to cancel out because you're looking for the PSI again, so that's how you're going to set them up. Feet on the bottom. So 12 foot divided by 2.31 foot. 12 foot multiplied by 0.433 PSI. And major factors, canceling your feet out, leave you with the answer in pounds per square inch. 12 divided by 2.31 is 5.194, and 12 times 0.433 is 5.196. They're going to round. Both round to 5.2 PSI. Question number 8. A rectangular tank measures 8 feet by 15 feet. Water in the tank is at a depth of 7.25 feet. What is the pressure in pounds per square inch on the bottom of the tank? Same formulas. Again, looking for PSI. Get the feet on the bottom so they cancel out. 7.25 divided by 2.31. 7.25 times the 0.433. Feet cancel out, leaving your PSI. Gives you an answer of 3.138 PSI and 3.139 PSI. They both round to 3.14 PSI. So that was just 8 questions, just going over them. It's pretty simple, pretty straightforward. But if you're studying this and something you've never done before, it's nice to go through and learn step by step. Like I said, this has helped me studying for my exam. If it helps you too, that's great. Thanks.